What's poppin', dogs? It's Mr. Allen, about to solve a couple logarithmic equations in this video. And of course, got to check for those extraneous solutions anytime you're dealing with a function that has domain restrictions, and logs do. Can't take the log of 0 or negative numbers. So we'll check that in the end after solving. This first one here, got log base 3 of x plus log base 3 of x plus 8 equals 2. So on my left side, I'm going to condense that into one logarithm, and I'll have log base 3 of x times x plus 8 equals 2. And if you'd like, you can throw an extra set of parentheses around that so the whole argument is in that log base 3. Now I'm going to distribute on the inside there, so x gets distributed to both the x and the 8, and I get log base 3 of x squared plus 8x equals 2. If you wanted to jump right to that step, more power to you. I like to show a lot of the steps here so you're not like, wait, huh? How did you get there? Next move. I can't just drop the log like I would do if I had logs on both sides. I have to rewrite this now in exponential form because I can't do anything how it sits. But if I loop and swoop, okay, trademark term by Mr. Thornley, not myself. I learned it from him. So we get 3 to the second power equals x squared plus 8x. It's a loop. That's a swoop. Rewrite it in exponential form. Okay, there's other ways to remember in that. That's the way I like to do it. 3 squared is 9, and I'm going to rewrite this. Let's see here. I'll write it as 9 equals x squared plus 8x. Subtract my 9. Now it's equal to 0 because I have a quadratic, which means I'm going to need to factor this thing or use quadratic formula. Fingers crossed, it is factorable because otherwise you got to bust out the big dog. Does anything multiply to negative 9 while adding to positive 8? Yes, it does. I have x plus 9 and x minus 1. Boom. Beautiful. Then I'm going to set those two factors equal to 0, so x plus 9 equals 0, and x minus 1 equals 0. So I'll get x equals negative 9, and x equals positive 1. You're welcome to just jump right to the solutions there. Again, I'm laying out all the steps here. Negative 9. When plugged back into my original, I have a negative argument for both these. It doesn't matter if it's just one of them or both of them. That is an extraneous solution, which means I've gone through all the proper algebraic steps, but it does not work in the original problem, all right? That's what an extraneous solution is. It's a great multiple choice question to ask that. Be like, what does it mean to be extraneous? Well, it means you went through proper algebraic steps. It does not work in the original. So fun fact, if, let's say that this right here, if that was the original problem, then the negative 9 would end up working. I'd have 81 minus 72, that's 9. Log base 3 of 9 is 2. Okay, so if the original's that, both will work, but it's not, okay? Now when I plug in the 1, I get log base 3 of 1, log base 3 of 9, all good. Log base 3 of 1 is 0, 3 to the 0 power is 1. Log base 3 of 9 is 2 because 3 to the second power is 9. Bingo, bango. That one works, the other one does not. Cool? Dope? Any questions? Didn't think so. All right, because nobody's here with me. It's just me doing math all by myself. It's more exciting than you think. All right, next one. Log of x plus 4 plus log of x minus 5 equals log of 7x. Why is there no base there? I'm all about that base, right? No trouble. Anywho, log base 10. If it's not written, it is the common logarithm, which is log base 10, okay? So we have the same base. I can condense on the left-hand side. We'll go with log of x plus 4 times x minus 5. I'm going to need to multiply that all out. Then we got log of 7x. And let's do this. Before I get too crazy and multiply that all out, can I just basically drop the logs now? One-to-one property of logarithms? Absolutely. Logs are gone because it's log on both sides. One single log on both sides. One-to-one property of logarithms states that then my arguments must be equal to each other if it's log and log. I cannot do that here. You'd end up having addition between them, not multiplication. So you have to condense them into one log first. It's one log on each side, hence the name one-to-one property of logarithms. Did I say that enough? All right, cool. So now I'm going to have x plus 4 times x minus 5 equals 7x. Let's multiply this all out, FOIL it, whatever you want to say. X times x is x squared, then negative 5x. 4 times x and 4 times negative 5 is positive 4x. Minus 20 equals 7x. I'm going to clean that all up. I'll get x squared minus x minus 20 equals 7x. We've got a quadratic. Let's set this bad boy equal to 0. Subtract 7x. I get x squared minus 8x minus 20 equals 0, time to factor. Okay? So I got x and x. Lead coefficient is 1, thankfully. No coefficient of 2, 3, or 4. Makes it a little more challenging. Nice AM method. What multiplies to negative 20 adds to negative 8, just like we had earlier. What is it? Negative 10 and positive 2. Dope. So I'm going to have x minus 10 equals 0, or x equals 10 for that matter. X plus 2 equals 0, so x equals negative 2. And now, do I have any no-nos here, right? Are there any that are like, whoop, no, that's not going to work? 10, when plugged back in, works for all those, all positive arguments. Negative 2 works for this one, but does not work for this one or this one, right? If it doesn't work in any one of those logs, it is an extraneous solution. So negative 2 is extraneous, proper algebraic steps, but the solution does not work in the original problem. So there we go, guys. One solution for both those. You can have 2 working solutions. It does happen. But we do always need to check to see if it works in the original anytime you're solving with logs. You can also have no solution. There are situations where neither of those are going to work. Just be like, no solution. It can't happen. All right. So there we go, guys. Hopefully that helps. If you have any questions, pop them in the comments. And thanks for watching.